Yeah, because Steven's going to be there.
Testing. Okay.
Perfect. Cheers, Paolo. I think we need to get Joe to Australia.
Ladies and gentlemen, can you take your seats, please?
Oh.
Wait, the man.
Yeah, I was just going to say. Oh, who's that guy?
Okay. Okay. What happened there? Oh, thank you, Gunther. So, following advice from my long-term career guidance counsellor, there will be no opening joke in this session. Okay, so this session is about what technological innovation in Earth observation, how it can positively impact societies. So our first speaker is the Global Open Data Lead at Amazon Web Services, Jed Sunwalt, and Jed has been working with GEO for a while. He is actually instrumental, along with myself, in setting up the GEO AWS Cloud Credits Program. So over to you, Jed.
Thank you. Okay, this thing's on. All right. Thanks. So, what I want to talk to or speak about today is what we've learned at AWS, sort of how we build technologies at AWS broadly, and how we've applied that to Earth observation data. But I'm not going to go too far into the weeds in terms of what we've done with Earth observation data, but talk at a very high level about how AWS approaches technology. So I'm going to start with a few quotes from people who are a lot smarter than I am. So this will sort of set the stage for you to at least maybe believe that I know what I'm talking about, or that what I'm saying isn't crazy. So first of all, I think we just celebrated the 30-year anniversary of the web. There was a little news cycle about that a few weeks ago, and which was really great to see. Obviously the internet has become, or the World Wide Web in particular, has become a quite marvelous and strange and sometimes terrifying thing. And it's interesting to look back 30 years ago and examine sort of what created it and what was the original vision or idea behind it. And there's this quote, so this is from an email sent in 1991, so this is a few years after it was initially started, where Tim Berners-Lee is explaining the project and the thesis behind the project. And I like this one line at the bottom here, which is that the World Wide Web world consists of documents and links. That's it. A very, very simple framework, if you even want to call it a framework. You just have these tiny pieces, loosely coupled things that have grown into what the web is today. And and I could talk my entire time about how the web has grown, but I'm not going to do that quite yet. So these are some quotes from Jeff Bezos. One thing that he says frequently, this will come up in all sorts of interviews that he does, where he says you can't skip steps. Amazon typically does not show off very flashy product demonstrations of what might be possible or anything like that. Instead, what we do is we build products and services brick by brick, taking each step along the way to make sure that things are built securely and are stable. We try to do this very quickly. We try to do as quickly as we can, but we don't skip steps. This is sort of a rule that we tend to follow. And then in his shareholder letters to shareholders that he puts out every year, he always says it remains day one. He's been doing this since he sent the first letter. So the first letter he sent in 1997, and he says, this is day one for the internet. We're just barely getting started. But day one is their building's named Day One, or the building that he sits in is called Day One in Seattle. Day one is a thing that we talk about at Amazon all the time, which is just this reminder that we're just getting started. Everything that we're doing with the internet and with our businesses, we try to approach from the standpoint that we're still innovating. We haven't figured out actually how to do this yet, right? And it's a way for the company to stay entrepreneurial and to move quickly, even as it grows quite large. And then I'm breaking a rule, like putting lots of words on a slide here, but this is from a blog post by Werner Vogels, who's the CTO of Amazon, describing 10 years of AWS. And the gist of this, I mean, you all can read this if you want, but what he's saying is that one thing that we've known all along is that you can't really predict what users are going to do. And I think this is kind of my main message to all of you and for the discussions throughout the rest of the day. From our standpoint, is that you're never really going to know what people are going to do with Earth observation data or like with any of your services. And so the approach that we take is to provide very low level, very basic services and have a very minimal feature set, and then listen to people and figure out what they need from there. But the point is getting out with sort of very, very low level services. And we call these things primitives. You know, we provide primitives. We don't provide very sort of like overwrought frameworks or platforms or things like that. We provide a set of services that are quite primitive. And then finally, Donald Knuth, if you know who he is, he created LaTeX. He's sometimes called the Yoda of Silicon Valley. He said that premature optimization is the root of all evil. And he said this in context of software development, where you'll have people writing code, and they'll try to optimize, you know, every single thing they can in the code. And what they usually end up doing is backing themselves into a lot of problems that they have to debug later. And he's like, don't do that. Actually, you know, get out working code first, and try not to optimize at the outset, because yet again, you probably don't know exactly what people are going to want to do with your code. So it's important to move quickly, yet, and one of the ways you move quickly is by not overfitting your services or the solutions that you're providing. And what I'm speaking to here are people who are working on platforms that are trying to do everything for everybody, because we've learned over and over and over again that approach likely doesn't work. So, and then finally, the Yiddish proverb, which is "Man plans and God laughs." So, as you can work really hard and build a platform or a framework that has a very full feature set that's very sophisticated, but yet again, you don't really know how people are going to use it, and so you want to be very careful as you make plans and invest tons of energy into building platforms and frameworks. So that's I'm through with my quotes. There are no more quotes. Yeah, exactly. So those are my thoughts for the day. So I'll talk just very briefly about what we've done with Earth observation data in the cloud. And the first thing to understand is the basic physics of how you work with data in the cloud, as opposed to traditional ways of working with data. So I imagine everybody in this room has probably downloaded data from an FTP server. I also imagine everybody in this room has been very frustrated by download speeds at some point in their life, which is fine. It's normal. Like, this is just how networks work. So traditionally, though, if you wanted to work with data, you have to download it before you work with it. And if you want to work with any large volume of data, that means you have to have a large volume of storage capacity available to you. What the cloud allows you to do is to not have to download data, or at least not move it very far. And instead of moving the data over a wire to wherever you are, you can deploy compute resources next to the data in the cloud. So Amazon S3 is our storage service. Amazon EC2 is Elastic Compute Cloud. It's our virtual server service. So you can turn on a virtual server next to data that's being stored in the cloud, or you can use other services that we have that are designed to run more powerful analytics workloads or data processing workloads. And then the nice thing about this is you can scale it up. So, you know, if you want to run a ton, you can do that, or you can scale it back down. It's not a big deal. Now, one thing that we've done over the years is we've been working with satellite imagery. So it was about 4 years ago that we started hosting Landsat data on AWS. And as we started doing it, we talked to a lot of Landsat users, and we learned about, you know, their access patterns and how they got Landsat data, and found there are a lot of inefficiencies in the acquisition pipeline. And actually one of the people we talked to was Peter Becker from Esri, who's a great help on this, who helped us understand the beauty of internal tiling in GeoTIFFs, and the idea that we could actually rearrange the pixels in a GeoTIFF that would allow people to get not an entire image of a GeoTIFF, or like not the entire object, but actually just part of it. So if you want to look at like one farm, one patch of rainforest, or something like that, you can extract just those pixels from a GeoTIFF if the file is formatted properly. And so what we started doing, we work with Planet, the satellite company, on this. We started getting all the data from USGS, and then processing it using GDAL to rearrange the pixels in the data and provide overview files and separate the metadata so that people could access the Landsat data programmatically. They could just access whatever they wanted, and they could actually write scripts to do it. But they could get precisely the data that they wanted for the analysis they were trying to do and nothing more. And what this looks like in practice, okay, so yeah, sorry, I forgot I had slides about this. So like previously you would have to get a tar archive, you would get 12, it's actually like 13 TIFFs, you'd have to get the whole thing. Now, so the first thing we did is like, well, let's just break that up so you can actually just get the TIFFs that you want. So if you just want these 3 TIFFs, you can get them. And then taking it a step further with the internal tiling, if you only want to get a certain patch of an image, you can get that. And what this looks like in practice is something like this. So this is a graph that a guy at Development Seed produced. If any of you have seen me speak before, I show this graph as often as I can because it's sort of a rare thing to have something like this. But Drew actually plotted out the time required to do a bunch of analysis that he was doing. So what you see on this plot are 90,000 points of him doing NDVI analysis over the course of about a year. And you can see on the left-hand side, there are these points that they took a little bit longer. So the y-axis is the time required to do the analysis. Those points take about like 300 to 500 seconds. So each analysis took that long. Once the data became available on AWS, it dropped down to about 20 seconds. And we did the math and figured out that that sort of being able to get the data in this way, very precisely and quickly from the cloud, saved Drew about 120 days of time. And this is just one researcher. So, we know that Landsat has tens of thousands of users. If we can save tens of thousands of users, even just a day of their time, that's a lot of time given back to science. And it's pretty gratifying. Now, but the other advantage of this is that if data is available in this way, you can build services on top of it that can actually analyze it and process it in real time. And so this is actually a visualization of an application. This is a web app that is in real time going and fetching pixels from S3, rendering them into images that can be displayed in a browser, all using open source code, all running in the web. And it's extremely inexpensive because actually no servers are used to run this. All the processing is done on the fly using a service we have called AWS Lambda that just executes code on demand. And by a similar token, there's Synergize has built its own applications. If you're familiar with Sentinel Hub uses some of the same serverless technology to also, in this case, do vegetation analysis, vegetation indexing over time on Sentinel-2 data. And so the beauty here again being that by focusing on very low level access to data and making sure that it's fast and reliable and extremely flexible, we've allowed other people to build more sophisticated services on top of it, do analysis more quickly, and ask more questions. And that's what we're really trying to get to. If we had set out to build, for example, Sentinel Hub, that would have been useful for a few people who want to use Sentinel Hub. But what we want are for anybody to build their own version of Sentinel Hub or build more bespoke applications on top of it. And the only way that we can do that, or what we found is one of the best ways to do that, is by enabling very low level of access to data. And so I'll leave you with this final thought, which is that going back to the premature optimization is the root of all evil idea, is that you can follow a certain path when sharing data where you can do a data dump where you're just putting raw data out there for people to work with, or you can go to the highly processed route and give people something that's highly refined and only useful to a certain audience. We believe there's sort of a sweet spot in the middle where if you focus on making data accessible, focus on ensuring that people understand that it's trustworthy and give them good documentation, you'll enable people to reach many, many more audiences with many different kinds of services at the end of the day. And with that, I will leave you and thank you for your attention.
Thank you very much. Moving swiftly on, we have Trent Kershaw, who is the Program Director for Digital Earth Australia. However, he's going to talk about Digital Earth Africa. Trent, over to you.
Thanks, Stephen. At Geoscience Australia, we were really happy in early March this year to be able to announce that the establishment of Digital Earth Africa had been funded. So this involved an investment from the Helmsley Charitable Trust of $10.2 million and also 10 million Australian dollars from Australia's Department of Foreign Affairs and Trade. So why Australia? We've had an absolutely huge success in Australia with the establishment of the Digital Earth Australia program. So what the Digital Earth Australia program sets out to do with the funding that we're provided from the Australian government is to increase the efficiency, the effectiveness, the productivity of government, and also to grow Australia's digital economy through the increased utilisation of Earth observation data and the insights that we can gain from it. So that just clicked over itself. That's nice. So there have been so many presentations on, different data, different corrections, analysis techniques, etc., that have come up throughout this workshop. We use so many of them. I won't bother going into them in the interest of time. But we are pulling open data, open government data, in correcting it, and pairing that up with Open Data Cube in order to ultimately deliver decision-ready products that make a difference to a whole range of users, such as land and water managers, mining companies, the agriculture industry and the supporting tech sector behind that, policy agencies, etc. So I guess I want to talk just a little bit about the way that we go about making this difference. When we're talking about something that is such a base context like Earth observation data, there are so many things that you could do with it. How do you figure out what to do? How do you make sure that what you do makes a difference? So that's why we always seek to make sure we're working with real users to co-design with them decision-ready products that make a real difference from them, that they can make a decision on the back of. So through rapid prototyping, absolutely being always willing to throw something that doesn't work out the window, we do what we can. And we're always targeting automation in this as well. And this is for many reasons. There's been a lot of talk about reproducibility of our products, of our science here. Automation is the best way to do that. But it's also a reliability and efficiency thing. Every moment that we're spending manually cranking a handle on some sort of correction or delivering some sort of product is time that we're not spending working with real users to make a real difference. So I will indulge myself in one Australian example, which is a piece of work that we've been doing on mapping Australia's persistent water bodies. So we've been working in collaboration with a water management organisation in Australia. This is just a particular area of interest that shows the importance of taking novel approaches that don't necessarily involve humans. In this area, this water management company, using some rudimentary remote sensing techniques and also just visual checking, found no water bodies in this area. Using WAFs, our water observations from space product. I'm not sure how well you can see that, so apologies for that. But there are a whole bunch of little light blue areas on there. These are the persistent water bodies that our water observation product was able to find. So we've gone and mapped these persistent water bodies across the entire continent. So we have the maximum extent for every water body across the entire continent. Once we have this, it's really a pretty minor step to go one step further and say, how full is this water body? How empty is this water body? And in the case of things like on-farm water storages, when was this dam built? This is of particular interest to our Murray-Darling Basin Authority, where there is a lot of regulation around things like the creation of dams. So just to plug, this is a month or two away of being available as a on-the-fly polygon drill that you can go to on nationalmap.gov.au. So that gives you the idea of what a difference and what you might be able to see at a farm level. What happens when you scale this up and look towards a larger area? So on the left-hand side there, you can see how full each water body was in 2016. On the right, you can see how full they are in 2019. Blue means full, red means empty. It's not going to take a scientist to figure out that we're suffering from a pretty major drought at the moment. It's these kinds of images that really compel government decision makers. It is such a clear picture that says, honestly, we are in this much worse a situation compared to how we were 3 years ago. So, and all of this is possible thanks to the open data cube technology. The rapid prototyping methods that we use in terms of user engagement are absolutely enabled by Open Data Cube. Without it, we would be nowhere. So we heavily invest in Open Data Cube. Everything that we do is ultimately coming out of the Open Data Cube. So, and the great thing about this, we're dealing with global data, and we're dealing with software that works with that global data. There's no reason why many of the methods that we and other people are using on Open Data Cube can't be transferred to other parts of the world. So it really is a powerful thing. Obligatory Data Cube proliferation slide. I'm sure it's out of date, so sorry about that, Brian. But these are the people who are thinking about what they can do with data cubes. I think we've heard many more examples today as well on top of this. This is about the movement. This is about all of us working together and lifting all of ourselves to be able to gain more and more insight out of Earth observation data. I will give a specific shout out to the Africa Regional Data Cube, which was absolutely the thing that enabled a program like Digital Earth Africa to get up. It launched last year with 5 countries: Kenya, Tanzania, Sierra Leone, Senegal, and Ghana, and dealt with a whole bunch of real use cases that were of prominence and of relevance to those areas. Huge support from GPSDD, GEO. Thank you for the donation of cloud services from Amazon. Brian Kilo from CSSEO and his team took the lead in building this. And what they did by doing all of this work was put us in a position where it was clear cut. Everybody could see that clearly there is value, there is need, and there's interest in using a service like the Data Cube. And ultimately, that led the way to being able to have a conversation about Digital Earth Africa at a continental scale. So in terms of transferring methods from one Data Cube to another, that water body example that I gave you earlier, we have tested it out in the ARDC. I can't say we were particularly surprised, but we were absolutely pleased to see that the method works in Africa. We will, of course, do testing before doing anything like scaling it out. But this is the power of us working together on common methods and common systems. So in terms of the case that we took forward, countries have clearly expressed a need to better have access to Earth observation data and the application of that data to apply to their national priorities, and particularly the 2030 agenda. And so we see Digital Earth Africa as being that solution to that. Or I should say the program is a big part of the solution to that problem, and the platform is the very beginning. So there was a whole bunch of support. There's a list of over a dozen countries there, a dozen use cases as well, from land degradation to pest control to urban growth, urban movement, natural hazards. The list goes on, and you can see on the right-hand side there as well the organisations that were actually actively advocating for this as well. So what is the Digital Earth Africa going to be? It'll be an operational data cube for all of Africa that delivers regular decision-ready products, not just research grade, but fully automated, run for every pixel across the entire continent. Leveraging off the work that we've done in Digital Earth Australia, ARDC, and all of those other data cubes. we will be setting up an institutional home with about 30 staff in it. And I do want to mention that that this is going to be a home that absolutely operates the DataCube platform, but more importantly, it will be the home of the outreach centre. The people who are going to go out and as we're doing in Australia, go and co-design new decision-ready products for users in Africa. This will be, I should say as well, that Australia is temporarily involved in the establishment of Digital Earth Africa. This will be an African program run by Africans for all Africans. So where are we now? We in Geoscience Australia have appointed Adam Lewis to take the lead on this establishment. So he's very busy establishing all of the ongoing governance, establishing the office, and starting to build a bit of a roadmap around the technical side of things, what the first products off the lot are going to be, and how we're going to go about broadly engaging in such a massive continent as Africa is. And with that, I'm finished. So thank you very much.
Great.
Thank you, Trent. Our next speaker is from Esri, or Esri, however you want to call him. His name is Steve Cope, not Cop. And Steve's program manager at Esri. He's been involved in GEO for a while. I know he's been involved in GeoGlows and the ecological marine units and a few other things. So he knows GEO a bit. So over to you, Steve.
Thanks, Stephen. And thank you guys for the invitation to participate. I was asked by the Secretariat to focus pretty specifically today on imagery and big data. And in the interest of time, I've left out all the high-level, fancy corporate slides that you may have all seen before. So, but we do have a pretty diverse audience here. And for those of you not familiar with our technology, ArcGIS is an integrated platform of not only desktop and server software, but we also have a back-end cloud hosting environment that we provide for our customers to make it easy for them to share their data on the web, to host web services and things like that. That cloud hosting environment known as ArcGIS Online is a mix of Amazon and Azure infrastructure, has about 20 million data sets and apps that were shared by about 875,000 users. And we serve about 1.5 billion services a day. It is federated into the GEOS portal search. So now, the majority of people here involved in GEO either are using or have access to Esri technology in some way within their organization or through one of our mini grant programs. And if you don't, I'll share an initiative at the end that might be of interest to you. So with that intro, it's good to be day 3 because I got to leave out a bunch of other slides. There's some key things that have been discussed that we agree with pretty strongly. Well-organized collections of Earth observation data, i.e. cubes, analysis-ready data, publishing of open services instead of using data download, leveraging available standards, and sharing reproducible science as Jupyter notebooks. So traditionally, the way that we accessed imagery was, we would download data to our desktop and do our analysis there, but that didn't scale very well. So we started putting data in big archives, and we would move the analysis closer to the data, and that worked pretty well, but then image data got really big, and so now we do everything in the cloud. So now we can access terabytes of data dynamically with the analysis happening near the data, as Jed was describing. Our infrastructure runs in Amazon, in Azure, or in a local private cloud that you build yourself. We have pre-built Amazon AMIs. We have cloud builder templates and chef scripts and all kinds of things if you want to roll your own, but it's also very easy to just spin up an instance in Amazon. So we've been working in Amazon. Our customers have been running our software in Amazon for almost 10 years. We've been putting imagery and image services on the web in collaboration with USGS for almost 20 years. So we have a little bit of background in this area. This is sort of a boring slide in some ways, but it's about really getting at the heart of how we deal with this. So what Jed was describing earlier about having large collections of imagery and wanting to be able to access small subsets of those, this is something that inside of our technology we refer to as a Mosaic dataset. And that Mosaic dataset is really just a database table that contains a bunch of metadata about the imagery, the footprint of the imagery, and pointers to where those pixels exist on disk somewhere. That structure is really the heart of how we interface with all data cubes. So whether you're talking about accessing Landsat in AWS, Sentinel in AWS, we've been working with Geoscience Australia last year on interfacing Esri technology with the Digital Earth Australia project. In recent months with Brian and his team on Digital Earth Africa interfacing. All of that is really about trying to figure out how to take that metadata and structure it in what we think of as a Mosaic data set. So we're just reformatting in the case, for example, of the Open Data Cube. We just read the YAML file and translate that into our database table. And that makes that data then immediately accessible. We're not replicating the pixel data. We're just using their metadata and pointers to the pixels in order to access it directly. And then all of the analytic and data management capabilities of ArcGIS are available against Landsat in AWS, Sentinel in AWS, Digital Earth Africa, etc. So there are a few things I wanted to share that we've learned about storing Earth observation data in the cloud. And this is really about maximizing performance and minimizing cost. Some people play with our Landsat Explorer app and they wonder how we make it so fast, because we're accessing the same buckets of pixels as everybody else. So we're primarily using S3 with a little bit of ephemeral storage, but we've moved away from cloud optimized GeoTIFF that Jed was describing, Peter, my colleague, had been involved in. So we now use a format called MRF, which was developed by NASA JPL. In our tests, we've found that it can be from 15 to 35% faster than working with COG, and it's available in GDAL. And then there's a compression format that we use with that can be lossless or lossy, that can provide a 25 to 45% performance benefit over COG with deflate compression. This was something that was developed at Esri, but is available in GDAL. It's also available in GitHub as DLLs and SO files and C++ source, however you want to get to it. It's all out there. We encourage you to use it. If you're currently using GDAL, you actually already have this in your stack because it's there in your GeoTIFF already. So anyway, if you're using COG, I encourage you to take a poke at these. I have a bunch of tables of performance stats that we'll be publishing in an upcoming article if you're interested in those. There's two approaches to image analysis that have been talked about by a number of presenters. One of those is what we'll call dynamic analysis, where we're working with local or regional analytic functions, where we're just working with individual pixels or small neighborhoods of pixels and maybe drilling through time at those locations. Those are the types of operations that can be done very quickly on the fly. And then we have a set of persisted analytic functions, we'll call those global functions, that need to read larger amounts of data. These are things that take a fair bit of effort in order to parallelize and often are run in a situation where you want to store a persisted result. So when we run these things, the first category of those would be the dynamic image services. It's a very simple approach where we have a single server and we're accessing that Mosaic data set through a variety of clients. But if we wanted to scale that up into a distributed big data solution, we can add additional processors. It scales dynamically. And a key piece of that at the bottom is also the distributed raster data store. So we developed a storage approach to use in the cloud that allows us to store the data in multiple locations so that we can actually have parallel I/O on the data. A lot of raster analysis functions are fairly simple computationally, so the processes get I/O bound if you have a single I/O pipeline. So this allows us to scale very nicely up to hundreds of parallel processes that we've been running against. We have a large suite of analytic functions available, and if you don't like one of the ones that we provided, you can also plug in your own through Python or R or some of the common deep learning toolkits that are available. Had a slide out of order. Anyway, there's a bunch of the parallel and distributed computation tools that we have available. And if you wanted to chain those together, you can use Python or other approaches for chaining those workflows. I wanted to specifically mention some of the machine learning data integration work we've been doing, because the machine learning process is really, it's a process, right? So it's not just about applying an algorithm. Those algorithms need to be trained, and in order to train those algorithms, we have nice tools for doing that. And we integrate very closely with TensorFlow and CNTK and others. A few examples here. This is some global Landsat processing. This was the full global coverage running on 32 cores, 200 processors in about 2 hours and 48 minutes. Similar example, in this case, a more computationally intensive. We're looking at about 400 gigabytes of imagery, doing a segmentation and classification, and then writing an output. This was run on 10 nodes, 20 cores each, so 200 processors in a little over an hour. I'm going to skip this one in the interest of time, but apps are really important because I wanted to get to the end here, which was to introduce a way that you can all get access to this. So since we're talking about innovative approaches here, a few months ago we launched something called the Africa GeoPortal. The Africa GeoPortal is a free, open platform as a service of our technology. It doesn't give you all of the big data raster analytics for free, but it gives you quite a bit of data as well as analytic functions and the ability to host and share data. It's africageoportal.com if you can't read that. So terabytes of data that we're hosting, as well as pointers to larger, many terabytes to petabytes of data. So that set of terabytes doesn't include pointers to things like Landsat and AWS, Sentinel and AWS, and other things which are there. Shaded in there is the Digital Earth Africa initiative, which we're working with Brian and team on. So when that's available, we expect to make that available as well. But the Africa GeoPortal provides not only data and analysis tools, but also the ability to build custom portals for nations or specific projects, an agriculture portal, a national portal, to a way to share workflows through Jupyter notebooks, a way to develop custom hosted applications without having to write any code. There's more things here than I could probably talk about in the time allowed. But I encourage you to check out africageoportal.com if you wanted to take a look at this. And then finally, if you weren't familiar at all with any of the imagery capabilities in our technology, there is a book that's available for free as a PDF download that has a corresponding workbook available for it. There's a MOOC, a massive online open course, 6 lessons that gets offered a few times a year that's free, as well as about a dozen free training lessons available on a site called learn.arcgis.com. And with that, I will finish and take questions later. Thank you.
Thank you, Steve. Okay, so now we are going to move on to, we've heard a lot of talk about the DIAS. Now we're going to hear about the Japan DIAS, which is something very different. So Miyamoto-san is the executive manager from one of the programs at ICHARM. ICHARM is the International Center for Water Hazard and Risk Management. Over to you, Mamoru.
Yeah. Thank you, Chair. So I'm Mamoru Miyamoto from ICHAM, that is a UNESCO Category 2 center. The ICHAM stands for, as Chair mentioned, International Center for Water Hazard and Risk Management. That's why our activity is a risk reduction for the water-related disasters. Then today I'd like to introduce our activity for the making societal impact by utilizing the Earth observation through the DIAS. The DIAS, I mean, is different from the Copernicus DIAS. According to the agenda, it is the Japan DIAS. So there are some global frameworks for the risk reduction of water-related disasters. But one of the most significant frameworks is the International Flood Initiative. That is the joint initiative among the international agencies such as UNESCO, IHP, WMO, UNOSDR, UNU, IHS, and IHR. The IHR is the secretariat of IFI. The IFI is going to promote the establishment of a platform on water resilience at disasters, in line with some global agendas such as Sendai Framework, Paris Agreement, and SDGs. Then this platform activity consists of 6 target activities: data integration, the flood early warning system, the climate change impact assessment, sediment disaster prediction, economic assessment, and contingency planning. Then this platform formulation is much recommended by the high-level panel on water, so-called HLPW, convened by the Secretary General of the United Nations and the President of World Bank. According to the outcome document of high-level panel on water, so-called Making Every Drop Count, platforms on water resilience and disasters among all stakeholders should be formulated in the country to facilitate dialogue and scale up community-based practices. So based on this recommendation, we are promoting the establishment of a platform on water resilience and disasters in some countries. This platform aims to contribute the risk reduction of water-related disasters. In order to do that, we are utilizing Earth observation, showing like here. So, for example, the AMSAR2, MODIS, Himawari 8, GSMAP, and Pulsar. The AMSAR2 can be used for the drought prediction and high intensity rainfall prediction. And the MODIS can be used for the simulation of hydrological processes such as the snow melting and evapotranspiration and so on. The Himawari 8 helps to understand the movement of cloud, and GSMAP is a strong tool for the near real-time flood forecasting. Sometimes we use 3B42RT from NASA as well. And so Pulsar is archiving the status of major rivers in the Asia, like that. Then by integrating those kinds of Earth observation data into Japan DIAS, we will be able to monitor, analyze, forecast the water-related disasters hazard as the activity of a platform on water resilience and disasters. Then, here, let me briefly introduce the Japan DIAS. So the Japan DIAS has the extra large volume data storage of 25 petabytes and the high-speed network in addition to the analysis server. The DIAS, Japan DIAS archives not only Earth observation, but the in-situ data in the field of the health, biodiversity, the urban, the agriculture, disaster reduction, and so on, for the purpose of operational use. For example, in Japan, there are some rainfall data. Then, every rainfall data, such as a gauge, ground gauge, radar, satellite rainfall, and GPV are archived in the DIAS. Then let me back to the explanation of the platform activity. This is the concept of platform, what we are going to do. We are assuming 3 steps. We will start from data archiving in terms of damage, hazard, and social economy. Based on this data integration, we will be able to identify, monitor, and predict the impact due to the changes of society and climate in order to contribute to the policy making and the community of local practices. Another important thing is capacity development. So we will provide some opportunity for capacity development for the practitioners and the policy makers in order to make it sustainable. So far, the platform activity has been launched in the 5 countries in Asia: the Philippines, Indonesia, Myanmar, Sri Lanka, and Pakistan. The IFI framework itself is a global scale, but we started with Asian countries, and we will expand as a region and a global scale. From now, I would like to introduce the platform activities in the case of Philippines. In the Philippines, so this is an institutional framework. So we have 2 co-chairs under Secretary of DPWH, Department of Public Works and Highways, and under Secretary of DOST, Department of Science and Technology. Then we also identified core organizations, DPWH and Pagasa Meteorological Agency, and the Department of Science and Technology in the Davao region, where is the hometown of President Duterte. So this is kind of the governance development based on the multi-stakeholder engagement. That's why all relevant stakeholders are involved in this platform. Then, so this platform in the Philippines has launched from the 2017. Then, so we could publish the concept of platform and the data sharing guideline through a series of meetings. And so last February, we had a 3rd plenary meeting. Then we are now facing the implementation stage. The platform activity should be localized and customized into the target country. Then so in case of Philippines, so we identified the holistic view of what we are going to do. Then so data-based integration, we will develop the near real-time flat early warning system and climate change impact assessment and economic assessment. So from now, I would like to introduce each activity. In the data integration, so all relevant stakeholders submitted their own data into DIAS. Then, so this is absolutely creating the synergy among the different stakeholders. Then, so Japan DIAS can integrate in-situ data and observation data. This is quite a strong point for this platform based on the multi-stakeholder engagement. Then, as a first step, so we identified a list of data like this in terms of damage, hazard, socioeconomic. Then, so yellow one has been collected already and archived in the DIAS. So at the same time, we also identified the responsible organizations. Then, so they submitted this data. And so we also prepared the template of the metadata in order to easily share the data among platform members. And we also prepared the uploading system of graphic user interface. Then so they use this interface for data uploading to DIAS. The next one is a real-time flat farming system. So in this system, so we are going to use all available data for the flat forecasting. Then so in the DIAS, Japan DIAS, so we conduct the flat forecasting and monitoring. So then so monitoring information can be compared with ALOS2 by then so we can validate the reliability of our simulation. And so forecasting information can be utilized for the flood prevention and evacuation activities. So far, this is still ongoing. So we have developed the preliminary system of this real-time flood forecasting system. And so in future, we will add more predicted rainfall and radar information into that system. The next is climate change impact assessment based on GECM and application of work model for the downscaling. So we identified the impact of climate change by comparing between the past and future climate. In case of Pampanga River Basin, which is the prototyping area, so we found that the monthly rainfall is not so significantly increased, but extreme rainfall will increase in future. This is another case in the case of Davao River Basin. So in case of Davao River Basin, the monthly rainfall during summer will increase, and the extreme rainfall will also increase. This kind of knowledge and new findings should be considered in the policy making. Then this economic assessment is still ongoing, so we will conduct the assessment based on the two factors, so robustness and the resilience. And so by comparing the GRP, so gross regional product, between the before and after disasters. Another important aspect is local community of practices. Then so based on our analysis, we can identify this kind of flood hazard images according to the return period, 10 years, 30 years, 100 years. But this kind of information is not sometimes understandable for the local people. That's why we need to translate this information and make it understandable for the local people. Otherwise, local people cannot come up with the meaning of information. Then we scored flood risk in the district-based analysis. Then we could successfully identify the hot spot of flood risk in the district. Then it is a future aspect. So we discussed and addressed for each component of platform activities, but we will add more the contingency planning and the development of capability for the stakeholders and local communities. So we will keep this platform activated and consolidated in the future in order to create a societal benefit. So my presentation is all. Thank you so much.
Thank you. Arigato. So now we have two final speakers on one topic. We have Chris Atherton, who's a Research Engagement Officer at the Pan-European Data Network for Research and Education, GEO, and we have Andres. Maybe I'll let Chris just hand over to Andres when you're finished.
Well, thanks very much, Steve. I'd just like to thank the Secretariat as well for inviting us to speak. Hopefully I do the invite proud. So what we'd like to talk about is how the research and education community are adapting to the changing nature and needs of researchers in the context of GEO. So I think before I start, I'd just like to try and define who we are, because people sometimes misunderstand what we do and what we are. To do that, I need to explain what a digital commons is. So the concept of a commons is it's a collection of resources that are managed by the same people who own it. It's not owned by any one individual, it's owned by the group, and collectively they all manage that. But really, we've created a network across Europe. We are the pipes that everyone's been talking about that no one wants to use anymore. But we're more than that. And in this evolving world that's constantly changing, both in industry and in academia, new disruptive technologies and concepts are coming along that we've got to respond to. It's a new paradigm. Back in, I can't remember when, there's a computer scientist called Jim Gray who worked at Microsoft, and he came up with the idea of we're in the fourth paradigm of science, which is driven by big data. And a lot of the recent developments that we have are, in a way, rationalization of that same concept, like what Jed was saying earlier. We're still at day one of the internet. And just going back in time, in the 1970s, we had ARPANET that was set up, which connected the universities in the US together. A few years later in Europe, a similar thing started to happen. So we had universities in a country that clubbed together and bought fibre between each other so that they could communicate together. Sometimes it was a government department that did this, and they connected up all of the universities and research institutes in their own country. This was the start of the NRENs, the National Research and Education Networks. They needed to talk to each other across Europe, and then that's where we were set up. It's been called many names over the years, but it's currently called the GEO network. But we're more than just a network. We're a community, and we're dedicated to helping researchers get on with the research that they want to do and removing the technological barriers underneath that distractions. And like this team of intrepid explorers, the NREN community has been adapting to the conditions of the day. Apologies for the cheesiness of that line. GEO's not alone in this. GEO's part of a global community. And where a research network hasn't existed, we've tried to help establish them. So we've worked in Latin America, in Africa, and in Asia to help create these regional networks, who then go on to help create the national research networks. And where the national research networks have existed, we've tried to connect with them and bring everyone together. So we've helped to set up this global digital commons that's a not-for-profit communications system for research and education, dedicated just for their use. And some of the developments that we've brought out from this global working is the likes of EduRoam. So, quick show of hands, who here knows what EduRoam is? Cool. So, for those who don't know what EduRoam is, it's a global Wi-Fi roaming service. If you use your username and password from your institute, you can go to any other participating institute and get Wi-Fi access for free. Most times you don't even have to click a button, it just connects directly to the Wi-Fi. It's available in 101 territories worldwide, and last year I think we had about 2 billion global roaming authentications. EduRoam isn't just the only thing that we've developed. The latest concept that came out of our previous project, which ended in December, is EduTeams. So this is a means of creating virtual teams to access common resources for that particular community. So like those explorers in the previous slide, you can have a researcher, a citizen scientist, you can have someone from industry all working together, accessing common resources together via their own institutions or organizations' username and password. So the same one that you use to log into your workstation. And it's not just the latest technology that we helped to develop. And I should say that EduTeams follows the ARC Blueprint architecture, which was helped to develop with a number of e-infrastructures. And then now I'll go on to say, we don't just do technology, we also provide professional services. One thing that we are quite proud of is the work that we've done for Copernicus. So the European Space Agency, based in Italy, run the Copernicus ground segment and also the distribution of the data from their central hub. They wanted to connect to the researchers, but the data centers hosted in or located in Germany. And due to the way that some constitutions were set up, it wasn't possible for an Italian institute to purchase connectivity in a German, from the German research network. So we stepped in as the middleman, and we helped to set up this link directly to the ESA Copernicus data hub. Last year I announced that we'd upgraded from 10 to 100 gigabytes. It's still at 100 gigabytes. It's roughly about 30 gigabit per second that's used. But over the space of the year, we've realised that, and in fact, it was ESA who told us as well, 70% of all ESA's global Copernicus traffic goes across that link. That's about 2.5 petabytes a day of data that goes across. And we even move the Copernicus data that EUMETSAT produces via the global research networks. But with the development of cloud technologies, obviously, and with the advent, of course, of the European Open Science Cloud, we are evolving again, so that researchers can get on with the things that they want to get on with instead of worrying about the technology. And that's where I hand over to Anders Steyer. Hope I got your surname right. Excellent. Who's going to talk a bit more about the OCRA project.
Thanks, Chris. Good afternoon, everybody. It's great to be here. I want to introduce to you a great opportunity to deliver and adopt Earth observation services at scale. As most of you know, Europe is the largest producer of scientific data in the world, and the European Commission wants to increase and stimulate the usage of that data as part of the European Open Science Cloud through a cloud-based approach. The project I want to introduce to you is OCRA, part of the European Open Science Cloud. It's called Open Clouds for Research Environments. GEO leads the project. CERN is there as well. RIA, Trust IT, ERSC is a member of the group. And what we want to do is stimulate the adoption of commercial cloud and Earth observation services, help suppliers deliver, and help the research community to adopt these services. For the Earth observation part, we are targeting those service providers that build on top of the DIAS platform and create user-facing services. We want to help them deliver, and the researchers, we want to help them to use those offerings. Practically, what will we do? We will launch a pan-European tender, a procurement that will launch in October. We will run this on behalf of 10,000 institutions in Europe, because GEO represents the NRENs, as Chris told you. The NRENs represent the research and education institutes. That brings quite a unique scale. So we have 10,000 institutions in the tender. The outcomes can be used by them through ready-to-use contracts. We also have available 9.5 million euro to stimulate adoption by users. So contracts and adoption funds. I think this is a great opportunity for you as a researcher to become part of this, to use the offerings. If you are a provider, to join the tender and to deliver, to become part of that European Open Science Cloud through ready-to-use contracts. So OCRA, in a nutshell, is in the middle. We help researchers with ready-to-use contracts. We want to make it easy and safe for them to use Earth observation services, and we want to help you as a provider to deliver at scale. You respond to one tender, you can deliver to 10,000 institutions. A couple of important milestones. The tender will go live in October this year. We are currently preparing. I want to encourage you all to join us, to give us input if you are a researcher, but also if you are a provider. There will be a webinar on May 24. There will be more, but the first one is on May 24, especially for you as EO community. Please come join us to talk about this. The outcome, the results, the framework agreements will be available from March 2020 onwards. Service delivery starts on April 1st, no joke. And then we also have that 9.5 million euro, which we will make available in 2020 and 2021. And I hope to be here in a year's time and tell you about the progress that we are making. Thank you very much.
Okay, thank you very much. Some of you have started putting questions on Slido, so that's very good. I will actually turn it around this time and I'll start with the floor. Do we have any questions from the floor? Okay, we'll start with Noah and then we'll move to Ethiopia.
Good morning, very interesting presentations. I'm Satya Kaluri from No One Knows This. I have a question for you smart people there, especially the one from Amazon. We, as an organization, when we build products and services, we are very much service driven by requirements. I'd like to know a little bit about when you provide these new opportunities. Are you tied to requirements, and do you go through verification, validation, check the box kind of a thing. Looks like it's a lot of let's go figure it out kind of an approach.
So it depends, right? So this is an unsatisfactory answer, but one thing that we've pointed out is like nobody ever asked for AWS, like no one wanted that. There was never a requirement to deliver anything like that. So on one hand, we produce things that we think are interesting, that we feel that would fulfill some sort of customer need. That's a way I think a lot of innovations happen. But at the same time, once we deliver, so any kind of service offering, and particularly because we have lots of customers that are highly regulated, we certainly need to adhere to requirements, right? So it depends, I guess, on the at what time you're reaching us, in the cycle of innovation. So I think at the outset of, again, I'll just use the example of AWS. I think when we were building AWS, nobody ever thought that like the government would use it. And now, it's used for like law enforcement. It's used for all sorts of applications that are extremely sensitive and have very stringent requirements. So I don't know if that helps answer your question, but we certainly respond to requirements when our customers need us to. I'll say that.
Thanks.
Tesfai?
Okay. Thank you very much for the presentation of presenters. It's very enlightening for us. So my question is on the Digital Earth Africa, in particular, how to deliver this service to all the African countries. Because as you may know, we have problem of data. Then in addition to that, we have processing tool issues as well. So in such data cube or whatever combination that is being proposed, the problems will be solved, I think. So my direct question, what are the costs involved? How is the data security? I'm talking about the products we derive from the raw satellite data. And then the sustainability of the service. Next 20 years, will we have? Thank you.
Thank you for the questions. So in terms of how we're going to go about doing this, the reality of what Jed was talking about just a moment ago in terms of nobody having asked for the cloud, to be honest, I don't think without innovation like the innovation that Amazon has done in driving this cloud world that we now live in, this would even be possible. So our intention in terms of implementation is to try and convince a major cloud provider to come on board, ideally as a philanthropic partner, dare I say, in this, and really make sure that we're putting this data into a place where people can stand up their own environments as well and still work with the data, still use the Open Data Cube software if they so choose, but they have the freedom to manage their own security, manage their own privacy, and make sure that they are comfortable with what's going on. In terms of ensuring the ongoing sustainability. Yep.
So I'm on the steering committee for Digital Earth Africa, and we've raised the first 18 million. We're in the process of raising probably another 12 million from one source and maybe another ongoing 5 million for 5 years. So the idea is not a 3-year project like you would get out of some of these big funding research type things. We're looking at a sort of 12 to 15-year program, and then working with like NEPA, the African Union Commission, UNECA and others to make sure that it sort of translates into the country's national budgets and into these other activities. From sustainability, from that perspective, that's the approach we're taking. So like Trent said, having some of these big philanthropic contributions and some money also going to some of the infrastructure and the other providers, that helps with it. The other big part is the capacity development. So I'd say probably 60% of the budget for Digital Earth Africa is for capacity development. So we're looking at things like train the trainer programs, working with organisations like RCMRD, AfriGist, the ones you'd know, to make sure that there's a long-term co-design and co-production activities as well.
Can I chime in? In on that? Okay, so I'd like to announce. I'm just kidding. I think one area of innovation that's sorely needed for all these kinds of initiatives is in business models. So I think this question of sustainability, I'm glad you asked it. I just want to point out, like, our program, the public dataset program that we run at AWS works. It's not just Earth observation data. We see this with the healthcare and life sciences community, working with genomic data. We see it with producers of large-scale statistical data, and also people working in the machine learning field that need large access to data or access to large data. I'm a big believer in cooperative models for this kind of thing, and particularly consumer-owned cooperative models, so where the consumers of the data are actually owners of the institutions that set these things up. And I expect we're going to see a lot of innovation in the business models in the years to come.
Thank you. John, you have a question? Can you just explain who you are?
Yes, sure. Thank you very much. My name is João Meto from Brazil. Actually, my question goes specific to Chris and Andres in terms of first, congratulate about EduRoam. That's EduRoam. It's a great product. And my question goes in terms of how the requirements and the demand from the research community can actually flow through this process. And I understand there's a webinar that can help understand a little bit. And in terms of the opportunities for supplies and agreements and supplies with the resource that you stated in presentation. So is that specific for Europe, or that it's it's broader in the world? Is there something that we can look for from other regions as well? Thank you very much.
Thanks very much for saying EduRoam's a great product. It's really nice to hear. I think, in terms of the OCRA project, that's focused on Europe at the moment. It's part of the European Open Science Cloud, and the funding that we get from the European Commission to put that together is focused on Europe. However, what we've been trying to do is, and we're in the very early stages of this, is talking to our global partners, like in Latin America, to try and use the concepts or the procurement techniques that we've developed in Europe, but use them elsewhere in the world. And I know that Red Clara are working, which is the regional research network that covers Latin America, which is Brazil is part of. They're looking at doing something similar, but that takes time to develop. With regards to the specifics about OCRA, I think I'd let Andres answer that question.
Thanks, Chris. The tender that we run in OCRA is open for all providers to respond to. It's an evolution of contracts we already have in place today. GEO has contracts in place today with, for example, AWS, Microsoft, Google, a whole range of European players for infrastructure as a service. What I think is nice to share with you some interesting data points. Already 18 countries, over 300 institutions are using those contracts. There is €1 million transacted every month through this. So we hope to see all those providers in the next tender again. As Chris said, we are sharing our secret sauce with our members across the world, our NREN friends. So for sure that is important also in terms of requirements gathering, etc., to show and have the same language, how we speak to suppliers. The funds themselves for OCRA are earmarked for Europe only, but we do hope to encourage suppliers to come up with more credit programs for research that could be made available outside of Europe as well. I know some suppliers do, like AWS. They have the Educate program for education. They have research programs. Some suppliers are more stingy, so we hope to encourage them to do something similar as well.
Thank you. So I'm going to take a couple of the questions from Slido. Probably for you, Trent. When do you expect Digital Earth Africa to be available for use in projects and analysis? What's the timeline?
So in terms of a starting point, we're being pretty bold and pretty ambitious. Our goal is that we are in a position to launch by the GEO Symposium in Canberra in November. At that point, we're hoping that we'll have Landsat data in the system. As I said, that this is ambitious. There is a lot of things that can go wrong between now and then, but that is absolutely our target. And what I'd ask anyone who is interested in, I guess being one of the first users of what we're doing is come up afterwards and let's exchange cards and make sure that we get everyone in contact with the right people to make that happen.
Okay, thank you. The next one's from me. This session is about societal impact, positive societal impact. I'd like to maybe ask Mamoru and Steve, in terms of like the work you've been doing, how do you see that translating? I'll maybe start with you, Mamoru. You talked about sort of flood prevention and evacuation. Can you see anything so far in terms of societal impact of the work that you're doing? And then Steve, maybe if you want to talk a bit about the Africa Geo Portal or some other things and how that is.
So from our standing point, our big challenge is the water-related disaster risk reduction. And so that's why we need to bring the cutting-edge science and technology into society. In that sense, Japan DSA is quite a strong tool for making societal impact, because the Japan DS is going to contribute the operational use of various kinds of data. And so data integration in DS can contribute to make it understandable for the local people and the stakeholders. Then so that information can be utilized for the policy making, decision making, the connecting with the prevention and the evacuation activities. This is our big picture.
So you talked about translating the flood risk data for local people. Can you maybe elaborate a little bit on that? Because I think that would have a...
we have to start with the scientific standpoint, but in order to make it understandable, we translated the kind of the expertise information into the index of flood risk and the hotspot of flood risk. That kind of translation can be used for the evacuation and prevention activity for the local people.
Is it being used, or it's still in development? Are they actually using it?
Yeah, in some target area, it is already used.
Arigato. Steve?
Okay, so I guess on the societal impact aspect of it, there's really sort of, Esri's role, and then there's the much larger impact that all of our customers have. And this, relates very closely actually to the Africa Geo Portal and what we're doing there. Because in the big picture, sort of long time scale, the thing that's really been happening for us and our customers throughout Africa has been a strong effort in more sustainable development and more responsible resource utilization, which is really at the core of Esri's corporate philosophy. We've had a conservation grant program for over 30 years. There's thousands of organizations we've given technology to, a large number of them in Africa, which on the shorter time scale, I guess I would say, more specific projects. Almost every natural disaster in the world, our customers are there in some way, because we're part of most national governments and most international aid agencies, as well as having a team of people who basically travel the world helping those people use our technology in disaster response on site. So the Africa GeoPortal is really just a way for us as an organization to sort of give back to Africa and try to help sort of raise the bar a little bit, help everybody out, get up a little bit further. And
Okay, thank you. There's a comment made which I actually agree with, but it's not for the panelists, because the panelists are invited. It's for the GEO Secretariat about this being a panel, an all-male panel. So if you are, I don't know who Anonymous is, I don't know if it's a woman or a man, but if there are more women who would like to contribute, then please speak to Paula or myself, and we'd be more than happy to put you on the next set of panels. This one is for Jed. Does AWF have plans getting all the Landsat 1 to 8 data on PDS, public data service?
Yeah. So short answer is yes. I'll explain a little bit more though. So we actually don't typically go out and just get data and bring it into the public dataset program. What we did with Landsat and Planet is sort of an exception there, where we recruited Planet to do this work with us, and it was a collaboration with them and a bunch of other folks. But USGS has publicly stated that they'll be moving the Landsat archive to AWS, and that work is underway. So I don't have a date or anything like that, but that's what they've said.
Okay. So Trent, you used a term, everyone's been talking about analysis-ready data, and you talked about decision-ready products. And Antje from Germany, from GIZ, she's asked, what are the criteria you use to decide that data are decision-ready?
Good question. This is why we need to work directly with the real users of our data. Not some conduit to real users of our data, but the actual people who are going to take your data and do something with it. The point at which a product is decision ready is the point at which the user says they can use it to help to influence a decision.
Okay. This one to Chris or Jean. With fiber and more REN links going into Africa now, why, with EduRoam access as per your map, why is it so limited on the continent? Why is it still so?
No, that's a really good point, actually. So EduRoam started in 2002, if I remember rightly. It started off with 6 countries in Europe and then grew from there. The way that we train up or spread EduRoam is by training the national research networks on how to deploy it and implement it, and they then go out to their institutions and connect them up and evangelize the use of EduRoam. That takes time. It takes a lot of time and a lot of effort. Previously, we focused on Asia because we helped set up the regional network there. The focus now is shifting more towards Africa. So in a year's time, we hope Western Africa and Eastern Africa, definitely. Southern Africa is already on its way with the likes of the South African Research Network, SANRAN, already deploying EduRoam in their countries. So next year, hopefully, we'll have a lot more blue around the African continent.
So just continuing on the Africa theme to you, Andres, there's a question about how can Africa benefit from the fund?
The adoption funds made available through the OCR project are earmarked by the European Commission to spend on European research. We will, however, share the outcomes of the tender, and I would like to invite other NRENs of the world, and I'm already in touch with many of them, to be in our global collective to make sure that we share our tender documentation, the outcome, the contracts. Happy to do so.
Okay, thank you. And maybe Steve or Trent, just reinforce, there's a question here about explain how Digital Earth Africa complements or competes with the Esri Africa GEO portal. I'd say it complements, but maybe one of you two wants to just explain a bit more.
Short answer, absolutely all complementary. Digital Earth Africa is a program that is about lifting the whole of Africa through increased utilization of Earth observation data. There are no rules beyond that. So honestly, anyone who's working in Africa towards the same goals is a pal. We're in discussions with Esri already about how we might be able to work together, but I'll hand over to Steve.
Yeah, I would agree. It's purely complementary, and as we've sort of seen, any well-organized collection of EO data is a good thing, and having open access to that is an even better thing. So really what we want to do is just leverage all the good work that is going into Digital Earth Africa and making that easily accessible to the large community of customers that we have across Africa.
Okay, so there's one final question, but I'm not actually going to pose it to you because it's going to take too long to answer, but I'm just putting it out there so that whoever anonymous is can maybe come and speak to you. But the question is, forecasting for sustainability solutions is important. How are your services developing or working with others to help develop this capacity? So that's a question. If anonymous wants to make themselves known, we can come and talk. Do we have any final questions from the floor before we close this all-male panel session? Okay, thank you very much for your attention. Round of applause, please, for speakers. I'm going to add something to the agenda because I'm moderating again after lunch. At 13:20, so at 1:20 p.m., I'm actually going to do a short number of slides on how private sector can engage in GEO. So if you want to see that, be back here at 1:20, and I'm going to just run through that before we start at 1:30. So if you want an extra 10 minutes for lunch and you don't want to hear me talk, don't bother. If you want to hear that, come back at 1:20. Enjoy your lunch.